Alkanes. Alkanes are saturated hydrocarbons that contains only single covalent bonds between carbon atoms. Saturated hydrocarbons are organic compounds having carbon and hydrogen only. Carbon-carbon single bond and maximum number of hydrogens with the carbon. Alkanes have the general formula CnH2n plus 2. While n is a positive integer, number of hydrogen will be double of carbon plus 2. For n is equal to 1, CH4, 1 carbon, 4 hydrogen. This is methane. N is equal to 2, C2H6 is ethane. N is equal to 3, C3H8, propane. Similarly, N is equal to 10, C10H22, that is decane. Structural formula. Structural formula of few alkanes are shown here. Structural formula can be shown in two ways, showing all the bonds carbon, 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 and carbon hydrogen are shown here, and condensed form. Here carbon hydrogen bonds are not shown. Homologous series. Alkanes have the homologous series. Homologous series is the family of organic compounds with the similar chemical properties. The characteristic properties of homologous series, they have the same chemical properties. In the each consecutive members, there are CH2 difference, the same functional group, show a gradual change in their physical properties, the same general formula. Functional group. Any atoms or group of atoms that gives the characteristic properties to a molecule is called a functional group. Organic compounds in the same homologous series have the similar chemical properties because they have the same functional group. So alkanes have no functional group, but they have the same general formula. Alkanes have carbon-carbon double bond, alcohol OH, carboxylic acid COOH. Isomerism. This is the one of the most important term. Isomers have the same molecular formula but different structural formula. So chain structure, position, and functional group isomers. These are the structural isomers. Isomers of C4H10. This is butane. This is the molecular formula. It has two different structures in butane and 2-methyl propane. Isomers of C5H12 pentane. It has three different structures: N-pentane, 2-methyl butane, and 2,2-dimethyl propane. Isomers of C6H14 hexane, N-hexane, 2-methyl pentane, 2,2-dimethyl butane, and many other isomers we can draw from C6H14. Alkane preparation from crude oil. Heated crude oil inserted into the fractionating column. The fractions will come out according to their boiling point. The lowest boiling point will come out at first, and the least boiling point come out at the bottom. The uses of petroleum fractions: petroleum gas, fuel for cooking and heating, petrol, fuel for car engine, naphtha, manufacturing plastics and detergents, kerosene, fuel for jet engine and oil stove, diesel oil, fuel for diesel engine, lubricating oil for lubrication and making waxes and polishes between paving road surfaces. Physical properties of alkane. Physical state: carbon 1 to carbon 4 alkanes are gas, carbon 5 to carbon 15 are liquid, and after 15 alkanes are solid. Melting and boiling point. When increasing carbon number, melting and boiling point increases because intermolecular force increases. Viscosity. Long carbon chain are much more viscous. With increasing carbon number, viscosity increases. Flammability. With increasing carbon number, flammability decreases. This is only the physical property of alkanes, decreases with increasing carbon number. So had the carbon number, less flammable because it's difficult to burn. Then in solubility in water, all the alkanes are insoluble in water because the alkanes are non-polar, but water is polar. Water has positive and negative side. Chemical properties of alkanes. Alkanes are known as paraffin because lack of affinity, so alkanes are generally unreactive. Though unreactive, we can burn alkane. Burning combustion reactions, we can burn methane and make carbon dioxide and water. Also heat is produced. This is exothermic reaction, so we can use alkane as a fuel. Substitution reactions, UV light is a condition for these reactions. So methane plus chlorine, you get chloromethane plus HCl, one hydrogen is replaced in the second reaction, another hydrogen, third reaction, another hydrogen replaced, and the last step, all the hydrogens are replaced from methane by chlorine in presence of UV light. Thank you.